students, welcome back from winter break. It's good to see y'all again. Before we get going with this video though, I just want to kind of clear something up about some feedback that I got with the survey that I gave at the end of the last semester. So there's a question about the notes and the videos and things like that. So I just want to let you guys know that all of the notes that we go through in class are on Schoology. So the PowerPoints and everything that I use are in Schoology folder underneath the instructional notes and videos folder. I would personally suggest maybe taking the notes first. So using the PowerPoint, taking the notes, and then watching the video, so that way you're not trying to write and listen all at the same time. If you write your notes first and then watch the videos, that way you can catch anything that you didn't understand, make a note to yourselves if I say something, or just pay attention to the process instead of trying to do everything, taking the notes, listening, and understanding all at the same time. Okay, I did get a lot of feedback about video length, so I'm really going to try to reduce the length of the videos this semester and really focus on making shorter video clips for y'all to watch. Okay, so we're going to start with our intro into stoichiometry. So let me go ahead and share this video here. So stoichiometry is a major concept in chemistry. It's really important. It's going to be something that we're going to be using in almost every unit this semester. Okay. So first off, what is stoichiometry? We were finishing last semester with chemical reactions. So what do chemical reactions tell us? Well, we can look at this particular chemical reaction and we can see that we've got one molecule of methane reacting with 2 molecules of oxygen gas to produce 1 molecule of carbon dioxide and 2 molecules of water, okay? So chemical reactions tell us the relationship between each reactant and the products that they're forming. And we can use those ratios that the chemical reaction is telling us to figure out how much we can make if we have different amounts. If we don't have 1 methane, for example, maybe we have six methane molecules now. Okay, so if we have 6 methane molecules, how many oxygen molecules are we going to need to react completely with those methanes? Well, since it's a 1-to-2 ratio, we're going to need 12 oxygen molecules to react with 6 methane molecules. So if these are our reactants, well, how much products are we going to be able to produce? Well, we can look at our reaction and see that we're going to be able to make the same amount of carbon dioxide as we have methane. So we should be able to make 6 molecules of carbon dioxide, and then we could make 12 water molecules. And that's what our chemical reactions are telling us, and that's what stoichiometry is. Stoichiometry is just putting it quantitatively. What is that relationship between our reactants and our products? If we have this many grams of reactant, how many grams of product can we expect to make? If we have this many grams of reactant, how much of this other reactant do we need to react completely with that to produce the products that we need? All right, the coefficients in our balanced chemical reactions are going to be really important in helping us to determine that stoichiometric relationship. Okay. Our chemical reactions and stoichiometry is just like a recipe. So if we have this recipe here, 1 banana and 5 strawberries gives us 2 smoothies. Well, how many smoothies can we make if we have 2 bananas and we have plenty of strawberries? Well, when we look at this recipe here, we can see that 1 banana gives us 2 smoothies. So we should expect that if we have twice as many bananas, we can make twice as many smoothies. So we should be able to make 4 smoothies because the ratio is 1-to-2. If we had plenty of bananas, we weren't going to run out of bananas, but we had 25 strawberries, how many smoothies could we make? Well, we can look at this relationship here and see that 5 strawberries gives us 2 smoothies. So if we have 5 times as many strawberries, we'll be able to make 5 times as many smoothies. We'd be able to make 10 smoothies. Okay. So what we were just looking at in that recipe is what we're going to be using in this particular unit, and it's mole ratio. The mole ratio is looking at our coefficients to tell us the relationship between a reactant and the other reactant, or the reactant and the product, okay? The mole ratio is going to be used as a conversion factor when we get into our actual stoichiometric conversions, okay? So when we look at this particular equation here, we have 2 moles of aluminum reacting with 3 moles of bromine to make 2 moles of aluminum bromide, okay? So let's take a look at this example here. we've got our balanced chemical equation, 2AlCl3 plus 9O2 yields 2AlClO3, 3. So if we're going to try to write mole ratios, I'm going to write these mole ratios as a fraction, as a conversion factor. So I'm trying to get my annotate tool here. Okay, so for letter A, if I'm trying to write aluminum chloride and oxygen as a mole ratio, I would say that we have 2 moles of aluminum chloride for every 9 moles of oxygen. That's letter A. For letter B, I'm talking about oxygen and aluminum chloride. I can see that I've got 9 moles of O2 for every 2 moles of aluminum chlorate. And then for letter C, aluminum chloride and aluminum chlorate, I could say that I've got 2 moles of aluminum chloride for every 2 moles of aluminum chlorate. Now, could you reduce that to that lowest ratio of 1:1 for the aluminum chloride to the aluminum chlorate? Yes, you can. I personally don't do that because when we're showing our stoichiometric sequence, I like you guys to see that it goes from the chemical reaction into this mole ratio here, and that those numbers actually came from the chemical reaction. If you reduce that down to 1:1, it's harder to make that connection back up to the balanced chemical reaction, which is why I write it this way. Okay? So let's take a look at this one. We've got, we have to start with a balanced chemical reaction first. So I can see I'm going to have 3 of these because I have 3 bariums on the product side. I see that I'm going to have a 2 here because I've got 2 phosphate groups over here on the product side. And that means I'm going to have 6 potassium chlorides. Okay, so when I've got moles of BaCl2 to moles of K3PO4, I can write this as 3:2, or I can write this as my mole ratio with the conversion factor style, 3 moles of BaCl2 to 2 moles of K3PO4. And over here, again, I can write it as a ratio like you would see in math where I've got 2:6, or I can write that as my mole conversion or my mole ratio conversion factor where I've got 2 moles of K3PO4 to 6 moles of KCl. And I'm going to let you guys do number 2 on your own and check yourselves with the Edpuzzle video that I'm going to make. All right, so let me know if you guys have any questions about mole ratios.